Hello everyone, I welcome you all once again to this wonderful session where we are going to discuss some important questions involving the Newton's second law along with the wedge constraint and the concept of pseudo force. So let us start. Question number 1 is diagram is on the screen. There is a wedge on which a block of mass small m is kept. So the question is, what should be the acceleration given to the wedge so that the block does not slide over the wedge? All the surfaces are frictionless. So if we draw free body diagram of the block with respect to ground, or we can say with respect to inertial frame, that is ground. So look, this is the inclined surface and this is the block of small mass m is kept and the angle of the inclination is theta. So the forces acting on this m, one is weight of the block small m into g, which is acting in downward direction, and there is a contact between the incline and the block, so there will be normal reaction as well, which is perpendicular to the contact surface. Let me call it as n. So these are the forces, and with respect to ground, the block should also move with the same acceleration a as that of the wedge, so that there is no relative motion between the wedge and the block. Now if the angle of inclination is given theta, this angle will also be theta. We can say this angle will also be theta. So if we resolve, so there is no acceleration in vertical direction and only acceleration is in horizontal direction. So if we apply Newton's second law, so we can say n cos theta should be equal to mg, one equation. In vertical direction there is no acceleration, so net force must be 0, and upward, or we can say upward force must be equal to downward force. And we can also say n sin theta, mg will not have any component in horizontal direction because mg is acting in vertical direction. So n sin theta will be equal to mass of the block into acceleration. That is equation number 2. If we divide these equation 1 and 2, then we can say divide 2 by 1. So we can say tan theta will be equal to a by g, or we can say theta will be equal a is equal to g tan theta. That should be the acceleration given to the wedge, so that there is no sliding between the block and the wedge. Now we can again solve the same question. We can solve this question in non-inertial frame also. That is relative to the wedge. Wedge is non-inertial frame of reference because it is accelerated frame. So relative to the wedge. Forces do not change whether it is inertial frame or non-inertial frame. So the forces will be same. If we draw again free body diagram, mg will be acting in downward direction and the normal reaction will be acting perpendicular to the contact surface. Now, because we are drawing the free body diagram with respect to the wedge, so because the wedge is moving with acceleration a, so with respect to the wedge, non-inertial frame, there will be a pseudo force. Let me show it by double-sided arrow. The pseudo force is mass of the block into acceleration of the wedge or acceleration of the non-inertial frame, and the direction will be opposite to the acceleration of the non-inertial frame. These will be the forces. And with respect to wedge, the block is at rest. That is the condition. Block must be at rest. So vertical force must be equal to horizontal force. There should not be any vertical motion. There should not be any horizontal motion. This angle will be theta. So this angle will also be theta. So we can say n sine theta. This is the sine component of n. So n sine theta will be equal to ma. Horizontal force will be equal. Net horizontal force will be 0. And n cos theta must be equal to mg. Net vertical force must be 0. This is the pseudo force. So if we divide again, then we will get the same result. Tan theta is equal to a by g. From here we will get a is equal to g tan theta. Let us talk about another question. Now again there is a wedge of mass capital M and there is a block kept on the wedge. Now if the block is released from rest, or if the system is released from rest, what should be the acceleration of the wedge? That is the question. And all the surfaces are again frictionless. So acceleration of the wedge should be how much? Or we can also find out the acceleration of the block. So now again with respect to ground, if we draw free body diagram, do not use non-inertial frame of reference until and unless it is required. When we are stuck in solving a particular question in inertial frame of reference, in that case we can take use of non-inertial frame. So if we draw the free body diagram of the wedge, then the weight of the wedge is acting in downward direction and the ground is giving a normal reaction in upward direction because there is a contact of the wedge with the ground. So this is, let me call it as R. R is the normal reaction given by the ground to the wedge. Along with that, the block is also in contact here. So the block will also give another reaction perpendicular to the contact surface, that is, let us say N. And the wedge is moving towards right. The wedge will move towards right when the block is moving, sliding on the block is sliding over the wedge will move towards right. A is the acceleration of the wedge. Now this angle is again given theta, so this angle will also be theta, or we can say this angle will also be theta. So we are not interested in vertical direction because the question is to find out the acceleration A. So if we write this equation along horizontal direction, so the only force along horizontal direction is n sine theta. N sine theta is capital M into A. That is equation number 1. Now if we know the value of n, we can easily find out the value of A. So to find the value of n, again draw free body diagram of the block with respect to ground. Again we are drawing with respect to ground. Let us see. As I told you, whether the frame is initial or non-inertial, the force does not change. So the weight is again acting in downward direction, weight of the block is acting in downward direction, and the block is in contact with the inclined surface of the wedge. So it will give the normal reaction to the block, which is same as the normal reaction we have shown on the wedge. They are action reaction pair, Newton's third law. If this angle is theta, this angle will also be theta. This angle will also be theta. Now, with respect to ground, what will be the direction of acceleration of the block? Will it be down the inclined plane? The answer will be clear no. Because with respect to wedge, the direction of acceleration of the block will be down the inclined surface, but with respect to the ground, it will not be same. We can make use of our uh, concept of relative motion. So we can say acceleration of the block with respect to ground is equal to acceleration of block with respect to wedge plus acceleration of wedge with respect to ground, isn't it? This is the concept of relative motion. So acceleration of the block with respect to wedge is AR, let us say. This is relative acceleration. The direction is this, and acceleration of the wedge is towards right, that is A. So the vector addition of AR and A will be the actual direction of block, direction of acceleration of the block with respect to ground. I hope that is clear to you. So we do not know the exact direction of acceleration of the block with respect to ground. Now, if we resolve the forces along this angle is theta, this angle will also be theta. So along the incline, if we resolve the forces, so what we can say, n will have no component. So it is mg sine theta. This direction will have mg sine theta. So we can say mg sine theta is equal to, the only force is mg sine theta, is equal to, or if we write along the incline, then AR will come into picture, which we are not interested in. We need to find out the value of n only. So that is why if we resolve the components along this normal direction, so what we can say, the component of AR is 0 along the normal direction. This will be the acceleration in this direction will be A sine theta, isn't it? So we can say mg cos theta, mg cos theta minus n is equal to ma sine theta. I hope this expression is clear to you. From here we can find out the value of n. So n will be equal to mg cos theta minus ma sine theta. If we put the value of n in above equation, then we will get mg sine theta then cos theta minus ma sine square theta will be equal to capital M into A. Right. So from here, if we take this term towards right, then we are getting A, that is capital M plus small m sine square theta will be equal to mg sine theta cos theta. So acceleration of the wedge is equal to mg sine theta cos theta upon m plus m sine square theta. I hope this is clear. We can also find out the acceleration of the block with respect to wedge. Acceleration of block with respect to wedge. If we see, this is the direction of acceleration AR. If we apply the Newton's second law along the inclined surface, normal reaction will not come into picture here. Mg is acting in downward direction. A will be in this direction. A. So this angle is theta. So mg sine theta will be equal to mg sine theta will be equal to m AR minus this angle will also be theta. So it will be AR minus A cos theta. From here we can find out AR as well because we already know capital A. Now this is how we have drawn the free body diagram with respect to the ground. For non-inertial frame, that is with respect to wedge, if we draw free body diagram, look how the things changes. The result will not change though. So this is small m, the weight is acting in downward direction, mg. The normal reaction is perpendicular, this is n. Now because wedge is moving towards right, so there is a pseudo force which is opposite to the direction of acceleration of the wedge, ma. That is the pseudo force, fps, pseudo force. This angle is theta, and this is the acceleration of the block with respect to wedge. This angle will also be theta. You can see this angle will also be theta. So along the inclined surface, or now there is no motion in the direction, in the perpendicular direction. The block must be in contact with the wedge, that is wedge constraint. So there should not be any motion in the direction which is perpendicular to the contact surface. So we can say n plus ma sine theta should be equal to n plus ma sine theta should be equal to mg cos theta. So from here n can be written as mg cos theta minus ma sine theta. This is the same expression. This is the same expression we have obtained using the free body diagram with respect to ground. So this is how we can get the same expression using the pseudo force. Similarly, if we want to calculate AR, then resolve the component along the inclined surface. So n will not have any component, so it will be ma cos theta plus mg sine theta is equal to m into AR. So from here we can find out. If you see this expression, mg sine theta is equal to MAR minus A cos theta. They are same. I hope this is clear. Now one more question. Another question is, again the system is released from rest. Find the acceleration of the wedge. The wedge will move down the inclined surface. So we need to find out this A. And also we will find out the acceleration of the block with respect to the wedge. So first of all, draw the free body diagram of the wedge with respect to ground. Angle theta is given. So here this is acceleration A. The forces acting on the wedge, one is capital M into G, vertical downward direction, and there is another force which is normal to the contact surface between all the surfaces are again frictionless. So the normal reaction by the inclined surface, let me call it as R, and there is a normal reaction here by the block as well, that is in downward direction, let me call it as N. This angle is theta. This angle will also be theta. So we can say n plus mg sine theta. The forces acting along the inclined surface is n plus mg, capital Mg. N plus capital Mg sine theta will be equal to capital M into A. The only unknown is n. If we get the value of n, we will get the value of acceleration. That is our equation number 1. To find the value of n, again draw free body diagram of block. Now with respect to ground, let us draw with respect to ground, with respect to inertial frame first. So this is the block. The weight of the block is acting in downward direction. The normal reaction by the wedge is in upward direction. These are the only forces. So if I ask you what is the direction of acceleration, what will be the direction of acceleration of the block with respect to ground? So your answer must be downward. Why? Because there is no horizontal force. These are the only forces. It must be downward direction. Or we can say the wedge is moving in this direction with acceleration A, and the block will be moving with respect to wedge in horizontal direction. Let me call it as AR. Acceleration is AR. So the resultant of A and AR must be downward. That is for sure. This angle is theta. Now our objective is to find out n. So what we can do is apply Newton's second law in vertical direction. This angle is theta. So if we apply Newton's second law in vertical direction, mg plus n must be equal to m a sine theta. From here we can find out the value of n. N is equal to ma sine theta minus mg. If we put the value of n in equation number 1 here, then we will get the value of acceleration of the wedge. We could have drawn the free body diagram with respect to, we could have drawn the free body diagram of the block with respect to wedge also, with respect to wedge. That is non-inertial frame of reference. So in that case, this is the inclined surface. The weight of the block is acting in downward direction, mg. The normal reaction by the wedge is acting in upward direction. Along with that, there will be a pseudo force which is acting in this direction. That is m into a. And this is the direction of motion of block with respect to the wedge. So according to wedge constraint, this angle is theta. There should not be any motion in vertical direction. The block and the wedge should always remain in contact. There is no relative motion in vertical direction. So from here we can say n plus ma sine theta must be equal to mg. Upward force must be equal to downward force. So from here m is equal to mg minus ma sine theta. If you see, this is the same equation which we have obtained, ma sine theta minus mg. Just a second. Mg plus it should be mg minus n. it should be mg minus n is equal to ma sin theta. So n is equal to mg minus ma sin theta. Mg minus ma sin theta. Mg minus ma sin theta. Now to find AR, again in horizontal direction, so we can say apply Newton's second law in horizontal direction. The only force is ma cos theta is equal to m into AR, or we can say AR will be equal to A cos theta. AR should be equal to A cos theta. Then only the direction of acceleration of the block with respect to ground will be in downward direction. So we can easily find out AR as well. So that is all. I hope you have understood these questions. Thank you. Enjoy. Take care.